Hello and welcome. I am Mustafa Farag, and I have a keen interest in making complex concepts accessible and easy to understand. With a very diverse background in civil engineering and hydroinformatics, I have navigated through the challenges of working in very different projects, not only in terms of software development, like huge legacy code and open source software, but also the technology used in these projects, like machine learning and data pipelines, high-performance computing applications with CUDA, and finally, data visualizations and 3D modeling. I have worked in research environments during my PhD, then in a very dynamic startup company, and finally in a big company with multiple software products. I'm here to share what I have learned with you. And today we are diving into the world of Git and explore how it can improve the way we handle code research projects and simulations. Whether you are a student or a senior researcher, or just curious about improving the workflow of your projects, you are in the right place. So let's get started. First off, what's Git? In short, it's a version control system that lets you track changes to your code, collaborate with others, and revert to previous versions when needed. Think of it as a time machine and collaboration platform for your code. Imagine you are working on a climate simulation model, and one day you decided to tweak the code to improve accuracy. A week later, you found out that your model predicts snow in the Sahara. Something went wrong, right? But what? With Git, you can easily compare your current code with the version from a week ago and identify the changes and fix the issue. Now, let's talk collaboration. Say, you and a classmate are both working on a Python script for a shared project. And instead of emailing files back and forth, with Git, you can both work on the code simultaneously, merge your changes seamlessly, and avoid any confusion over who did what and when. Reproducibility is key in research. With Git, every change to your simulation code and result is tracked. This means you or anyone else can replicate the study months or years later, understanding exactly how the results were obtained. Ever worried about losing your work or messing something up as you try new ideas? With Git, your code is backed up on a remote server like GitHub, and branching allows you to experiment without risking the main project. If an idea doesn't work out, just switch back to the main project, and no harm is done. In this video, we are starting at the very beginning. I will kick things off by diving into how to create a repository on GitHub, setting up SSH Key for secure connections, fine-tuning your Git configuration for a smooth development experience. Then I will go through the most common Git commands that you need to work with others, like create a repository, solving conflicts, merging. Then I will make things a bit more complicated by explaining how to undo changes using the reset, revert, and the checkout commands and the difference between them. By the end of this video, you will have your own repository ready to go, a secure connection to manage it, and a personalized Git environment set up on your machine. So if you have your laptop ready, let's get started. So first I'm going to create a GitHub repository in order to use it for this tutorial. And you can do that by going to the plus sign in your repository and then write a nickname for the repository. And first you have to choose your account with whatever organization you are part of. After that, write a description for the repository and choose whether public or private. After that, choose whether to add a readme file and .gitignore. You have to specify which language for that, and then choose the license. And here we choose GNU, and then create repository. So you can do that in your profile account or in a part of organization, and that's what I'm going to use here. So I created this already. I called the repository Git tutorial, and now we are going to clone this repository locally in our machine. And in order to do that, we have two options: to use HTTPS or SSH. SSH, you have to set up a SSH key in order to enable your computer to connect with GitHub and to clone the repository. But here we are going to use HTTPS. So copy the link and then open a terminal and browse in your computer where you want to clone the repository. Then type in the terminal git clone and then paste the link that you have just copied from GitHub, and then press enter, and then you will find all the steps that Git have done to clone the repository locally. So now if we browse, so now if we check the content of the directory, we will find Git tutorial. And if we go inside this Git tutorial, we will find all the files that we choose that GitHub create. And that's the .git ignore and license and readme file. So what is SSH? SSH, or Secure Shell, is a protocol that allows you to securely access and communicate with remote servers. By using SSH key with Git platforms like GitHub and GitLab, you establish a secure channel, ensuring your code transfers are both private and protected. So first things first, let's open a terminal or a command prompt. This will be our primary tool to create SSH keys. So check if you have SSH installed in your PC. If so, type echo user profile between 2% signs to know where is the default location for your keys. Now to generate a new key, type SSH-keygen followed by some flags, and now on the screen, and replace your comment with something meaningful to you. And the -t ed25519, this is an encryption algorithm, and the -c will give your key a label, so make it easily identifiable. Now press enter to accept the default location for your key. This ensures your SSH is stored in a standard directory, making it easy accessible. With your key generated, it's time to add it to your Git platform, and we are using here GitHub as an example. So navigate in your GitHub account, go to setting, then find the SSH and GPG key under the access section in the left panel. Click the green new SSH key button. And here paste the public key we have just generated. And that's it. Now you have successfully created SSH key and added to your Git platform. And this not only enhances your workflow security, but also make it more efficient. So you don't need to provide your password every time you want to push a commit to GitHub. Configuring Git is very important. It personalizes your Git environment, ensures your commits have the correct author information, and setting the correct configuration at the beginning saves you from a lot of headaches that can happen during the development process. So let's set up your user information. This is important because every commit uses the information to identify the author. It's easy to view your current default Git configuration simply by typing git config --list in your terminal, and you can see the username, email, and default editor. Now let's set up your user name and email. So type git config global user.name, then type your name, and this name will appear in all your commits. For your email, type git config global user.email, then type the email that's associated with your Git repository in GitHub. Next, let's configure the default text editor for Git. This is the editor that opens up when you commit or edit Git configuration. For example, to set Sublime text as your editor, type git config global course.editor, then between two double quotations sub -n-w. If you insert the whole path to where Sublime is installed, make sure that the path is correct for your system and use // or double backslashes in the path. The path should be enclosed in single quotes, while the entire command, including the flags, is enclosed in double quotes. The flag N opens a new window for editing, while the flag W tells Sublime Text to wait, doesn't return immediately until you have finished editing. So yeah, finally, Git is highly customizable. For instance, you can set aliases for your frequently used commands, or set up Git to use a specific merge tool. However, this advanced settings is not in this video, but I might create another video for that. Besides the README license and git ignore files, you will find another folder in your repository, the .git folder, which contains the metadata and objects that Git uses to track the history of your project. The .git folder is created in the root directory of your repository when you initialize or clone any Git repository. So when you open it, you will find first the head file, which is a reference to the current checked out commit or a branch. Then you will find the config file, and that's containing configuration options specific for this repository. And then you will find the description file. There is also the hooks folder, and this folder contains scripts that are invoked at a specific point in Git workflow, such as before you commit or before you push. I will create a separate video to talk about something called pre-commit hooks, and these hooks you can integrate into your repository to run tests as part of your commit. After that, you will find the info folder, which contains the exclude file. This exclude file is exactly the same as the git ignore, but it doesn't get committed or shared with other people, so it stays in your local machine. Then the objects folder, and this folder stores all the content of your repository, including files and commit objects, and it is divided into subdirectories using 2-character names. You will also find the refs folder, which contains references to commit objects, and it is organized into directories such as heads, tags, and remotes. Heads are branches in the repository, tags are tagged commits, and remotes are references to commits in the remote repository. And finally, the index file. And this index file is sometimes referred to as the staging area or the cache. And it is a binary file that stores information about what will go into your next commit. Now we will create and add our first file to Git. So let's create a text file and call it a recipe. And in this recipe file, we will add some ingredient. Let's say tomato and cucumber and vinegar. Then save the file. Now, if we want to check how does Git detect these new changes, we can use the status command. So type git status. The status command will give you the name of the branch you are in and the files that you have changed. Now we are going to add the changes to the staging area using the add command by typing git add, then the file name. If we check the status again, the color will change to green. It means that the changes that we have made just moved from the working tree to the staging area. And to commit the changes, we will use the commit command by typing git commit, then using a flag m followed by a message. And the message should be a brief description of the changes. Then press enter. Then you will see how many files and lines were changed, added, or deleted. If we check the status again, Git will tell you how many commits you are ahead or behind the remote branch. And here we have one commit ahead of the remote branch. And finally, to push the changes to the remote branch, we will use the push command simply by typing git push. After that, we can open the repository in GitHub. We should see the changes that we have just pushed. Now, if we have been working for some time and we want to see the history of the repository, what was the commits that we have done a couple of days ago? For that, we can use the log command. So type git log, one line, and this will show you the timeline of the commit in your branch, with each commit has its own message and commit ID. Now, if we want to create a new branch to develop a new feature or fix a bug, we can do that by typing git checkout -b, then the branch name. Let's call it here, add new ingredient. If we check the status again here, it will tell us that we are in the new branch. Let's say we added the wrong ingredient, but did not add it yet. So the changes are still in the working tree. We can discard these changes using the restore command by typing git restore, then the file name. Now, if we check the recipe file, we will find the changes are gone. Now let's add the right ingredient, commit, and push them. Since this is the first time we use the push command in this branch, our local branch doesn't know yet the name of the remote branch in GitHub. So we have to add this information to the push command. So we will add this using a flag called setUpstream, followed by the remote name, and our remote name here is origin, then the remote branch name, and the remote branch name is the same as the local branch name here. And that's it. We have pushed our new branch to GitHub. Now we can go to GitHub and create a pull request to review our changes. So once you open GitHub, you will find this message in top to create a pull request. So press on it and give the pull request a descriptive name, then press create pull request. Now, if you press on the commit tab, you can see a list of all the commits you have done in this branch, and that's exactly the same as what you can get from the log command. If you switch to the file change tab, you can see the differences between your branch and the main branch. Now I'm going to create another branch and commit some changes as if there is another colleague working on another branch, on another bug, and when he finished, the changes that he made conflicts with our branch, and we have to solve this conflict. So I created another branch from main and called it add salt and added an ingredient salt in the recipe file and pushed this new branch to GitHub. Now, if you go again to GitHub and create a pull request for this branch, add salt branch, we can compare both branches to see the conflict. So I will also open the pull request of the first branch, the add new ingredients branch. Now we compare if we compare the recipe file in both pull requests, we can see that we have added two different lines in the recipe file. Salt in the first and lettuce in the second. And this difference is the reason why both branches will conflict. So let's go back to our add new ingredients branch and then change the upstream to add salt instead of origin add new ingredients. So type git branch set upstream to equal origin add salt, then the name of the name of my branch, which is add new ingredients, then press enter. Now, if we check the status, it will tell us the differences between both branches and that both branches have diverged. To get the changes from the add salt branch to our branch, add new ingredients, we will use the pull command. The pull command fetches the changes from the upstream branch and tries to merge them to our branch. If there is no conflict, we can just add and commit these changes. But if there is a conflict, you have to solve this conflict manually. So to manually solve the conflict, you can go to the file that has the conflict and search for the chevrons as you see here. So in the top are the changes in the working tree lattice, and then the equal separator, then the changes from the remote branch, which is salt. So to solve this conflict, we will definitely keep the lattice as this is the changes from our branch, and we also need the changes from the other remote branch. So we will keep the salt as well. So then save the file, add and commit these changes. Now remember that your local branch is add new ingredients and your upstream is add salt. So the name is different. And if you try to push the changes, Git will complain. So we have to change back the upstream. And to do so, we will use the same command as we used before. Git branch set upstream to equal origin, add new ingredients. That's the remote, and our local branch is add new ingredients as well. Now, if we check the logs, we will find the commit add salt from the branch add salt is added to our commit tree and to our branch. So now push the changes to the remote. Now, if after some commits we found an error and that the tests in GitHub are failing, and we want to go back to the last status of the code when tests were successfully passing, one of the ways to do that is by using the reset command. The reset command can be used to unstage files, modify commits, and alter the current branch history. There are 3 modes of the reset command: soft, mixed, and hard. And the default mode is mixed, where it moves the head to a specific commit and resets the staging area to match, but it leaves the working directory unchanged. So here I will add some wrong changes, commit and push them to explain the reset command. Now, to reset back to the last commit before these wrong commits, check first the ID of the commit using the log. Then type git reset followed by the commit ID. Now I have reset the commit tree to the status before the wrong content to commit. So before, the head was referring to the commit wrong content to. Now the head refers to the commit wrong content 1. If we check the status, Git will tell us that there are some changes in the working tree, and these are the changes that were in the wrong content to commit. so we can discard them using the restore command. Now I will repeat the reset command again to undo the wrong content 1 commit by resetting to the commit that was before that. Now, if you check the logs, you will not see wrong content 1 and wrong content 2 in the commit tree. One note here, you can directly reset to the commit before wrong content 1 in one step. So if you type git reset and followed by any commit ID, Git will undo all the commits that were introduced after this commit and return them as new changes in your working tree. Another way to undo changes that were already committed is by using the revert command. Git revert is a command used to create a new commit which undoes the changes made by a previous commit. Unlike the reset command, revert doesn't alter the existing project history, making it safer for changes that have been shared with others. The revert command only reverses the changes that were introduced in a certain commit. So if this commit added some lines, the revert command will delete these lines. And the opposite is true. If the commit deleted lines or even files, the revert command will return them. So I will create some wrong changes and I will commit them. So if you want to undo the changes on the commit wrong content 1, copy the commit ID, then type git revert, followed by the commit ID, then press enter. As you see here, the revert command tried to undo the commit, but it couldn't solve the conflict. So we have to solve the conflict manually. If you open the recipe file and search for the chevrons, we will find that the revert command tried to get the difference between our commit, wrong content 1, and the parent commit. And if it is successfully got the difference, it will reverse this patch. But if, like in our case here, Git didn't manage to get the difference patch to reverse it, we have to solve this manually, then add and commit the changes. If we check the logs now, we will find that a new commit is added to the commit tree. We can do the same with the commit wrong content too. Git checkout is primarily used for switching between different branches in your repository. It also lets you view past versions of your files. So if you want to view the recipe file at the commit wrong content to, type git checkout followed by the commit ID. Now Git will tell you that the head is not at the most recent commit in your branch, but rather detached, and that you can branch out from this point in the commit tree by using the switch command. Also, if you list the local branches, Git will show that you are detached to a certain commit. To go back to the most recent commit in your branch, simply check out the branch and you will find the head refers to the most recent commit. And with that, we wrap up our exploration of Git for today. I hope this session sheds light on how valuable Git can be in your work, enhance collaboration, and ensure that every step of your work is well documented and reproducible. In the description of this video, you will find a link to all the material I have used in this video. So thank you and see you next time.